Welcome to Eureka Math. This is Module 6. We are on Lesson 5, and today we're working on investigate patterns and vertical and horizontal lines and interpret points on the plane as distances from the axes. So we've got our x-axes and our y-axes, and we're going to talk about points along those axes, okay? And we're going to look for patterns. So let's go to our Learn book. Write your name, please. And use the coordinate plane to the right to answer the following questions. Use a straight edge to construct a line that goes through points A and B. So by straight edge, they mean a ruler to make sure that your line is straight. Okay, so we're going to go through line A and B. Nice straight line between there. Ooh, if I had a ruler on the board, that would be easier. Okay, and it's going to go all the way through. Okay, and I'm even going to draw an arrow because that line could go on for much longer, and I'm going to label it E. Now it's a special kind of Latin E, so it looks like that. Line E is parallel to so parallel means it runs along the same line, so it's parallel to the x-axis, right? This is the x-axis, okay? And it is perpendicular, that means it forms a 90-degree angle with the y-axis. Okay, so that's that. Plot two more points on line E. Name them C and D. So anywhere we want, I'm going to go here. This is C. This is D. Now you can go anywhere along that line that you want. That's where I'm putting them. Give the coordinates of each point below. So A is 1, 2, 3, 4. So this is 4. Remember, parentheses, the x-coordinate, comma, and the y-coordinate is 0, 1, 2, 3, 4, 5. So this is 4 here. Okay? So 1, 2, 3, I'm sorry, not 3, 4. 3, 4, and then your other parentheses, okay? And coordinate C, which I just put in there, is 4, 5, so 5, 4. Coordinate B is, so that's, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is right here. So this would be 11. 11, and my y-coordinate is on that line, so it's 4. Are you seeing the pattern here? 4, 4, 4. D is 5, 6, 7, 8, and 4. So this horizontal line is always going to end in 4 because it doesn't move and it's perpendicular to the x-axis, okay? What do all the points in line E have in common? They all have the same y-coordinate. Okay. Give the coordinates of another point that would fall on line E with an x-coordinate greater than 15. So this is why I drew an arrow, because this line could go on forever. Any line we want. So let's say my age, 25, 4. I'm kidding, that's not my age. You know I'm older than that. Okay, but any x-coordinate you want. You could give as many different ones as you want. Okay, the age you're allowed to drive is 16. The age you're allowed to vote is 18. 25 is the age you're allowed to rent a car in the United States. What other special things can you do? You can retire at age 62, okay? So that x-axis can be any number we want, as long as the y-axis is still 4, because that's going to make it all along this line. It'll always be on that line. Okay, good. All right, let's try again. Plot the following points on the coordinate plane to the right. Okay, so P is 1.5 and half. So 1.5 and half is right here. That's point P. Q is 1.5 and 2.5. So 1.5 and 2.5 is going to be right here. We're going to call that one Q. Then 1.5 and 1 1/4. Are you seeing the pattern already? It's here. Are. And 1.5 and 3/4. So 1.5 and 3/4 will be here, and that one's called S. Now, what did you notice about those? 1.5, 1.5, 1.5, 1.5. They all have the same X coordinate. So use a straight edge to draw a line to connect these points. Label the line H. Okay. You're using your ruler to draw a perfectly straight line, I hope. And this is our X, and this is our Y. And notice that the new line we created is also perpendicular to X, which means it is parallel to Y. And we're going to name this one H. Okay, but we're going to use that Latin H like this. Like cursive, right? Okay. In the line H, X equals what for values of Y? Look, 1.5, 1.5, 1.5, 1.5. So X is always going to be 1.5 on line H. Circle the correct word. Line H is parallel or perpendicular to the x-axis. So this is the x-axis, and it runs along here. Remember, we're creating a little 90-degree angle there. That would make it perpendicular. Those are our vocabulary words. I hope you know them. Perpendicular and parallel, super important. Okay. Line H is parallel or perpendicular to the y-axis. Here's the y-axis, and it runs straight up and down just like it. So it's parallel to the y-axis. What pattern occurs in the coordinate pairs that you know that line H is vertical? I know that it's vertical up and down because the x value doesn't change. The x coordinate, and I'm just going to put C-O-O-R-D period, that's a shortening for the word coordinate, is unchanged or always the same. Okay. For each pair of points below, think about the line that joins them. Okay, so we're not drawing them, we're just looking at them. For which pairs is the line parallel to the x-axis? Remember, to be parallel to the x-axis, the y is always going to be the same. Okay? So which pair of points below? We don't even need to plot them. We don't need to plot them because all we have to do is look at that y coordinate. So 2.2 and 2.4. Okay? Is this parallel? No, not parallel. How about this one? 3, 9, and 8, 9. So that has that y coordinate is the same. So yes, parallel. Okay? 1 1/4 and 2 and 1 1/4 and y. No, that's not parallel. It's actually perpendicular. And how did I know that? Because the x was the same. Okay? I didn't have to plot those to know that. I just looked for those patterns. Okay. For each pair of points below, think about the line that joins them. For which pairs is the line parallel to the y-axis? Okay. Parallel to the y-axis means it goes up and down, right? Parallel. Circle your answers. Okay. Now, what did we just say about numbers along this line? They have to have the same x value. Okay. So 4 and 6, no. 12 and 12, yes, but that means that they run this way. Okay, so this is actually perpendicular. Okay. This one, 3/5, 2 and 3/5, 1/5, 3 and 1/5, that's not parallel, it's not perpendicular. There's no pattern there. And this one, 0.8 and 0.8, okay, so those have two x coordinates that are exactly the same, so that is parallel to the y-axis. Goes up and down. Okay, so then give two other coordinate pairs that would also fall in this line. For which pairs is it parallel? So this is the one. So we can give any coordinates we want as long as the x coordinate is 0.8. So if you want to go 5.4, that's going to be on the same line. or 0.08 and 32, still going to be on the same line, okay, as long as the x-coordinate is the same. Number 5, write the coordinate pairs of 3 points that can be connected to construct a line that is 5.5 units to the right of and parallel to the y-axis. So parallel to the y-axis means that the x values have to all be 5.5. Doesn't matter what they are, 5.5 is my x for all 3 of these. Okay, oops, didn't mean to draw that, meant to draw my comma. Now, whatever your value on the right side is, doesn't matter to me because they're all going to be on that same line. Let's go 10, 42, and 6.5. Okay? Write the coordinate pairs of 3 points that lie on the x-axis, okay? So if it lies on the x-axis, right, here's x, what is the value going to be of y? Okay? It's not even parallel, it is the x-axis. So we want all of those y values to be 0, all of them, okay? So 0, okay? And here we can put any number we want. Let's go 1/2 and 4/5 and 37. Okay, any number you want as long as it lies on the x-axis, so the y value is going to be 0. Adam and Janice were playing Battleship, and we played it in lesson 4, and some of you are struggling a little bit, so we're going to keep practicing Battleship. Presented in the table is a record of Adam's guesses so far. Okay, so here's what he did. Hit, miss, miss. He has hit Janice's battleship using these coordinate pairs. What should he guess next? Okay, so first of all, do you guys remember how many points does a battleship have? A battleship has 4 points. That's important to know. So we need 4 points to sink the battleship. You sank my battleship. There used to be commercials that said that. Okay, so let's just go ahead and plot these points because it's just easier to visualize what we're doing. So there's the y-axis, there's the x-axis. And we're using whole numbers, so I'm just going to use my hashes as whole numbers. 3, 4, 5, 6, 7, 8, 9, 10, and then I'm actually going to draw, oops, a little bit further than that. Okay, and my line's going to continue there. And then this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is my highest one. Okay, so 3, 11. 1, 2, 3, 11 is right here, and that was a hit. So that was a big old hit. I'm going to put H for hit. And then 2, 11. 1, 2, 11 here was a miss. Okay? And in fact, if you were playing, you should be playing with colors so you can see what you're doing, but that's okay. 3, 10, 1, 2, 3, and 10 here was a hit. Okay? 4, 11, 1, 2, 3, 4, 11 here. Oops. Sometimes my line goes a little crazy. Okay? 4, 11 is here, and that was a miss. And 3, 9, 1, 2, 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 9, right here was a miss. Okay, there's only 2 possible answers here. 3, 9 was a miss, but 3, 10 and 3, 11 were hits. So look at that 3, 3. They're both on the, they're both perpendicular to that x-axis, right? Which means they run parallel to y. So this is a hit and this is a hit, but we need 4 more. And we know that this one is a miss, so it's not right below it. We're gonna have to go here and here to get 2 more hits, okay? Let's see. So that would make it 312 and 313. Okay, and those will both be hits. I promise you'll sink the battleship. Great. Now you can come back to your exit ticket, finish that, and then finish your homework, and you'll be all set.